Hello class, it's Miss Brown. Welcome back from spring break. These are the notes I'd like you to write on page 99. We are officially stopped with static electricity and we're moving on to current electricity. So electric current, remember, like the current of a river, is flowing electricity. So in electric current, the electrons are flowing through a loop, usually through a wire. So I have here a little demo. If my other video worked, you might have seen it. And here's just a battery and a light bulb and a speaker. And so if I just connect one side to my wire, it doesn't work. But what if I connect both sides to my wire? Here's one side, here's the other side, and it works if I connect both sides. So there are weird variables in this equation. The variable for current is I. I imagine it's like the wire is this line. That's my capital I, is the wire, because the current is mostly in the wire. The unit for current is amps or amperes, and it's abbreviated with a capital A. There are two types of current, AC and DC. There's a famous band with that name, and they named themselves after the two types of current. So AC current is alternating current. It switches directions, and it's the kind you get from a wall outlet or a wall plug. So it comes out of the wall, it comes through our power lines, and it goes down, and it comes back. And it's actually alternating direction. So inside here, it's going zzz. And for whatever reason, it's easier for that to go a long way, all the way from like the power plant to your house, than it is for direct current to go to your house. Even direct current or DC current flows one way in one direction. And we get that from a battery. So the current coming out of a battery is always going the same direction. It's always coming out the same direction, as opposed to the current that's from a wall plug that's going, it's alternating, it's switching. That's what alternating means, is to switch. And so we get an equation about how much current, we are going to only do math about DC because it's easier math. You're welcome. And we have this law called Ohm's law. Now, Ohm's law is V equals IR. I, again, is the current with the unit A, or amps or amperes. V is the voltage, and that's what you get from the battery. This is a 1.5 volt battery. I think a car battery is maybe 12 volts. 9 volt batteries exist. So the voltage is also called the potential difference or the voltage potential. If you see any combination of these words, voltage, potential, and difference, that means volts. It means the stuff that you get from a battery. It's the energy that really keeps the charge flowing inside of that circuit. And the units for voltage are volts, which are V. So the variable and the unit for voltage is both V. That's nice, that makes sense. For current, it's I for the variable and A, amps, for the unit. Some French guy named Ampere came up with it, I'm sorry. And then R is resistance. When I think about resistance, I think about Star Wars, and the resistance are the people who are fighting the Empire. They're trying to stop it. So resistance is what's inside of the circuit that's trying to stop the flow of charge. It's mostly from like the light bulb or the speaker or whatever is like using up that energy. But some of it happens because the wire isn't perfect. And so some resistance is almost like friction. We won't do math for the wire resistance, but it does exist, and that's what we're learning about tomorrow. The unit of resistance is named after this guy, Ohm. It's called ohms. But if we put a O there, it would look like a 0. So 1 ohm would look like 10, and that wouldn't make any sense. So we use this upside down U. It's technically omega. If you're religious, you might have heard the quote, I am the alpha and the omega. This is the letter at the end of the alphabet that Jesus was saying. He was saying, it's me, Jesus, A to Z. That's what Jesus meant when he said, I'm the alpha and the omega. I should be everything from the beginning to the end. But you don't have to be religious. It's just a thing that I know omega from. I thought I'd let you know. All right, so we're going to do a little bit of math. We can use that same triangle we've always used. I believe in y'all. Get going.